All right, ladies and gentlemen, welcome to Algebra 2. All right, Mr. Baker and I were talking because I think most, if not all of you, are going to end up with Mr. Baker next year. And we are kind of talking about where you're going to be next year and what are some things you're going to do. And I reached out and I said, look, I'm going to be finished with geometry. What are some things that I can do to help my class get them ready for you for next year? And one of the things Mr. Baker said was, let's get good at factoring. Let's practice some factoring a little bit. So this lesson and the next lesson for the week are going to just be on some factoring. Today's a factoring review. We're going to talk about factoring by the GCF, the greatest common factor, factoring differences of squares. So remember some perfect squares. Maybe we'll take a minute and write down some perfect squares. Numbers like 1, numbers like 4, numbers like 9. Let me turn my pencil on. There we go. So numbers like 1, 4, 9, 16, 25, because it's like 1 times 1, it's 2 times 2, it's 3 times 3, or it's 4 squared, 5 squared. Those are our perfect squares. And we're going to talk about doing some trinomials as well. So that's what we're going to kind of get to today. It'll be like I'll walk you through one, I'll let you try another one. So let's start off with GCF factoring. So when we factor by the GCF method, you're looking for the greatest common factor. So I'm thinking, what's a common factor of 6x cubed and of 3x? I'm going to take those two individually. So I recognize that because 6 is 3 times 2, there's a common factor of 3. And also there's 1x that's in each term. Remember, that's like x to the first up there. So the GCF is 3x. So then I divide each term by my GCF. So my GCF goes on the outside. And I can ask myself, what do I multiply 3x by to get 6x cubed? What's the other factor? So 3 times 2 is 6. And I need 2 more x's. So I get 2x squared there. And then 3x times 1 in this case is 3x. So that's factored by the GCF method. Why don't you take a minute and try the next one? Alrighty. So I'm looking at this and I'm thinking, well, there's an x in every term and the smallest number of x's is here. And it looks like they're all even, so I can divide by 2. So my GCF is going to be 2x. And when I divide everything by my GCF of 2x, I end up getting a 4x squared. I end up getting a positive 5x and a negative 4. But I made a mistake there. That's not a 4x squared. That's a 2x squared. So my apologies on that, huh? There we go. Get that back. So that's a 2x squared. There we go. So that's factoring by our GCF method. All right, if we're factoring by difference of squares now. So the reason why we call it a difference is because there's a subtraction between the two. And squares because they're perfect squares. For example, I know that x squared is a perfect square. X squared multiplies to x times x. And 81 is a perfect square. It multiplies to a positive 9 times a negative 9. That's where I get my 81 from. And I'm done. That's my factoring. So let's keep going. Let's take a look at our next one. I recognize that 16 is a perfect square, x to the fourth. Oh, x to the fourth, how about x squared times x squared? So we make our two parentheses. How about a 4x squared and a 4x squared? How about a negative 9y? Ooh, not 9. I'm bad today. 7y and a positive 7y. And you can put those signs in any order. As long as one's positive, one's negative, you are in a good spot. So that's our difference of squares. Let's keep rocking and rolling. My favorite, trinomials. So first of all, when I'm factoring a trinomial, again, I'm going to recognize there's going to be two different parentheses here. And what I'm doing is I'm looking for numbers that multiply to negative 20. I'm taking a look at that first. So negative 20 might be like a 20 and a 1. I'm going to ignore the signs right now. I'll show you how I fix that. A 10 and a 2. A 5 and a 4. And I think those are all the integer factors of 20. So now you got to ask yourself, which of these can make an 8? which of these can you combine to give you a positive 8? So that's where it's going to be a 10 and a 2, and a positive 10 and a negative 2 are going to make my positive 8. So that's where I get my 8 from, and notice that if I multiply them, I get my negative 20. Had to let the cat out. Sorry, cat was meowing. So take a look at the next one. Can you find numbers that multiply to 32 and combine to give you a negative 18? So 32, thinking 32 and 1. How about 16 and 2? Bing, bing, bing. How about 8 and 4? And I think that's about it. So let's take 16 and 2. And I got to make a negative 18. So the way I'll make a negative 18 is with a negative 16 and a negative 2. So there's factoring some trinomials. And we're going to keep going a little bit. Let's talk about factoring trinomials when what we call the a value is greater than 1. A is the number that's in front of the x squared. So I'm actually going to go, if you remember the previous ones, it was always like a 1x squared. Well, now we have a 2x squared. So you might remember doing this by grouping, factoring by grouping. And the way you want to approach that was you wanted to multiply 2 times 15 together, and you get 30. So now I'm going to find my factors of 30. So the factors of 30, let's see, how about 30 and 1? How about 15 and 2? How about 5 and 6? How about 10 and 3? And which of these can you combine to make a 7? Well, if you said 10 and 3, you were correct. So watch how I'm going to rewrite this term. I'm going to keep my 2x squared, but I'm going to rewrite my negative 7x using my factors of 10 and 3. So a positive 3 and a negative 10 will make me a negative 7. So maybe I'll do like 2x squared minus 10x plus 3x minus 15. So what I do is I break apart that 7x. I'm rewriting the negative 7x as a negative 10x and a positive 3x. Now, what I'm going to do is I'm going to group them together. I like kind of splitting it down the middle. I'm going to group the first two terms together. They have a GCF of 2x. And when I take out my 2x, I get left behind an x minus 5. And when I factor out my GCF of my other two terms, I have a positive 3 as my GCF. And check out that there's another factor of x minus 5 left. So one of my factors is x minus 5. And the other factor is the two GCFs, 2x and positive 3. So that's factoring by grouping, where you find out what numbers multiply to the product of the first and last. So I multiplied 2 and 15 to get 30, and figure out how they get to be 7. And I already know you're looking ahead. And you're going, I ain't multiplying 12 by 24. Me neither. So this is where sometimes it's helpful to do a guess and a check. Sometimes it's a little bit more efficient to do guess and check here. So let me do some guessing and checking. I'll start with the first term of 12x squared. I can multiply like a 6x and a 2x, and that's going to give me a 12x squared. And let me just, and again, I'm guessing. I don't know if I'm right or if I'm wrong. And let me try some numbers now that multiply to 24, like 8 and 3, or maybe 6 and 4, or maybe 12 and 2. But here's a problem with all of these pairs of numbers. If I plug those numbers in here, like if I do like an 8 and a 3, this term has a GCF. But if you look at the beginning, there's no GCF here. So if there's no GCF in the beginning, there can't be a GCF in the factors. So I can't do 8 and 3 because that's going to give me a GCF regardless of where I put it in. I can't do 6 and 4. I can't do an even number because these are both even. Ay, let's get the big eraser out. So I can't do that. So 6 and 2 as a start is not going to help me out too much at all. So let me think of another pair of numbers that might multiply to 24, like maybe 4x and 3x. And now let me think about those factors of 24. Like 8 and 3. Let's see, can I put an 8 and a 3 in where there's no GCF? What if I put the 8 here and the 3 here? And I'm just going to take a guess on that. So how do I know if I'm right? Well, let me multiply those two together. That gives me 32x. Let me multiply those two together. That gives me 9x. And if I do 32 minus 9, I get 23. Ooh, that was a good guess. So then how do I get it to be a positive 23? Well, I need a positive 32, so there's my positive 8. And I need a negative 3 for a negative 9x. So my answer here is 4x minus 3 times 3x plus 8. Yikes. Challenging factoring. But then again, welcome to Algebra 2.